Hi everyone, my name's Rusty Bowers. I'm a high school math teacher here at Belgrade, Montana, and I've been asked to make some GeoGebra videos and some lessons for those of you who want to learn about the program or get better at the program. I I use GeoGebra in lots of different ways. I use it not only just for to run a lesson, but I also use it for students to actively engage with. Here at Belgrade, we're one-to-one with tablets, so I have that luxury to have GeoGebra in our students' hands. But maybe you can take them to a computer lab or something like that. Yeah, so I also use GeoGebra to make worksheets and make the type of problems that I want depending on the geometry and algebra that I'm teaching. So I'll show you guys how to do that. Alright, so let's get started here. So I believe the intent of these videos is to take a NAEP question item and put some teeth to it, put some depth to it, and use GeoGebra to do that. So as I take these items like this question here, this angle bisector construction question, I just kind of show you how maybe we could use GeoGebra to set up a lesson that could help us maybe teach the concepts better. So for example, constructions, I know that when I was teaching the traditional model, because here at Belgrade we're changing to an integrated program, but when I was teaching out of the geometry book, these constructions were kind of just lists, and there's a bunch you do two, maybe three in a section. So you just give students steps, right? These kind of look familiar maybe. These would be the angle bisector construction steps, and it kind of shows them how to construct the angle bisector. Okay, there's also videos, like this is on mathisfun.com. There's a little video here that shows students how to perform the construction, and that's great and all, but do students really know what they're doing, and why are they doing what they're doing? Because as you can see in the video here, that it bisected that angle. That looks good, but why? What's going to keep students to remember that construction? Okay, so what I do with constructions is I try to connect it to special quadrilaterals here. And so what I mean by that is this shape right here. If you look at these 4 points that we have in the construction, this makes a kite here. So in a kite, in geometry, we say a kite is a quadrilateral, so this four-sided shape that has two distinct congruent adjacent sides. So adjacent meaning next to, right? So we know that this segment OA is going to be congruent to this segment OB, right? But they have to be different lengths than the green segments. So this is our kite that gets constructed, and so really in the construction you're just making a property of a kite, and one of the properties is this angle bisecting thing. And the way that I try to teach concept in my classroom is connecting the three rigid transformations, reflection. So if you reflected this upper triangle, it would reflect exactly onto this lower triangle, so therefore this angle must be congruent to this angle, to help kind of build concept that, okay, I can kind of mentally reason why these angles have to be congruent, therefore bisected. Okay, so let's use GeoGebra and let's have kids understand how to prove, because this looks like a kite, and I think that that's good enough, to buy in. Yeah, I can see a kite here. But let's teach that concept and go past the looks like a kite to proving that it's a kite. Okay, so what I would do is I want to take, I'm going to get rid of those lines there. I'm going to take a picture or screen capture a picture of this and save its image file. So the way that I do that, and there's only two ways that I know, you guys may know other ways than me, but I use a program called I think it's called GreenShot. This little icon here, yep, GreenShot is what I use for my screen capture. You get it at www.getgreenshot.org. But if you have Windows 7 or you have Windows 8, I think that both of those, Windows have the snipping tool, so if you click on the little start button, if you do have Windows 7 or 8, if you don't, you might need to get Greenshot, because you need to save the picture file. And print screen isn't good enough because we can't save the file with print screen. Okay, so if you do have Windows 7 or higher, if you just type like snip, for example, you get the snipping tool. So this is just a little screen capture thing that's in Windows. So I'm just gonna, you just click and drag on the area that you want to screen capture. So maybe this is the region that I want. Where did it go? Okay, there it is. There's the region that I wanted there. Also with the snipping tool, there's pens, you can write all over this if you want to. You could highlight some things, you can write on it, I believe, but I just want to save this this picture file. So I'm going to save it. I already have some saved here. I saved mine as angle bisector 2. Okay, so you would just save it into a folder, and then you're going to open up GeoGebra. So I'm going to close that out. Open up a GeoGebra file, and let's have a blank screen here. So if you have your grid lines or your axes shown, to turn those off, you just click the little toggle buttons up here. If you don't see those options, then this little arrow next to graphics is pointing to the right. It's closed that little menu, but if you click on the arrow, it'll drop down the options and we can turn off those axes and grid lines if you have them on. Okay, so now let's go ahead and put that picture in here. You probably have this ABC text tool showing here, but in this toolbox, to expand toolboxes, each one has these little red arrows on the bottom. So there's lots of tools in a toolbox, so you can just click on the arrow and there just drops down the tools that are in that toolbox, and you can see that GeoGebra has a lot of tools. And I'll try to make sense and just think out loud the way that I think about the environment here. But this is what I tell my students. It's just called the text toolbox, even though there's a lot more than text in here. I don't really know the name of it. But let's grab this insert image tool. It has this little flower icon. Okay, so when you click in GeoGebra to insert the image, you click at where the lower left corner of the picture is going to go. So I always click in the lower left corner of my screen and go find your picture that you saved. Here's mine, so I'm going to click open. So now I have that picture that I just captured from anything that you have. So this is how I use it a lot, especially if you teach out of the book and you have homework questions and you want those word problems that, you know, students to see the relationships. Take a picture of the problem and put it in GeoGebra and overlap the picture with the geometry that you want kids to see. So that's one way that I use pictures in GeoGebra. Okay, so let's talk about resizing and moving pictures around. So this picture looks a little small. I kind of want to make it a little bigger to use more of my space. And sometimes when you insert a picture, depending on the file type, it can be really big. So here's how I resize pictures. To do that, you can actually define the corners of the pictures as points. So what I'm going to do is grab my new point tool, and I'm just going to click on the screen and put 2 points. This is going to be like my bottom left point. This is going to be like my bottom right point of the picture. So to define the corners, what we do is right click on the picture, and you're going to go down to object properties. So we're going to change the properties of this object because we're going to redefine the points and the corners. So click on the position tab, and now it illustrates which corner we can make a point. So with the drop menu, I'm going to click A. That's my point A here. Notice it's now the left corner. And then corner 2, the bottom right, is B. And now get out of that menu. And now we define the corners to be the 2 points I placed, and you can move those points around and make your picture as big as you want, as small as you want, and orientate it any way you want to. So that's pretty neat. So now we have this picture here, and let's prove that this is a kite. So if this segment OA is congruent to this segment OB, then what we could do is make a circle that's centered at O here and make it go out to O or A and B. right? So let's do that. So I'm going to grab my circle tool. So circle with center through point tool. If you don't know, if you want to grab a tool and you don't know how to use it, just hover over it and you can see this little yellow window that comes up. You can see, like for this, it gives the name and then how to use the tool. So select center point, then point on circle. So the first point when we use this circle tool, the first point is going to be the center. So I'm going to click right where O is, and now GeoGebra is waiting for me to put another point down. So I'm going to click on either A or B, and we can see that that's actually pretty close. So I'm going to choose A here. Now to make things stand out in GeoGebra, change color, make thickness, or change the thickness. You can change like into dotted lines and things like that too. Like this is a dotted line. What you do is just grab your move tool. If you like shortcut keys, to go back to this move tool, this is what we got to use to select objects and move things around. You can just hit escape on your keyboard, and that'll just, if you do that, it just unselects everything that we have and defaults back to our move tool. And if you're ever using a tool and GeoGebra is just not doing it, you know you're using the tool right, but the computer program might have a little glitch or something, just hit escape on your keyboard and then it kind of deselects everything, and then grab that tool again that you were using and try again. So it's kind of a good habit to get used to. Okay, so we can see with the circle here that this distance CD is just the radius of a circle, and this distance CB is also a radius of the circle. So these two distances have to be the same length, right? So we can reason with students and show that circle. That's really what you're making with your compass. One thing about these little arcs, I'm not a super fan of that arc especially when we're teaching kids the process, because they're not really seeing the radii logic of circles. So they don't really know why these segments are congruent. They just do a little arc. I think once they understand the logic of the construction, and then to be efficient, they can use arcs, but they need to be able to explain why the construction works. So let's illustrate those radii being the same length. So I'm going to make some segments and put up some segments on top of the segments from the picture. So I'm going to grab my segment tool, and I'm going to make a segment CD. Just click on the 2 points you want to be endpoints, and the segment here. Now, if we want to change their properties, grab your move tool. A couple ways to select multiple objects. We have 2 segments here, and notice GeoGebra categorizes your objects, so it puts a title to them, and you can click on the title and it'll select all of the objects in that group. So if I wanted to change all the points together, I would just click on the word point, and notice they're all selected. So for these 2 segments I made, maybe I'm going to click segment, highlight them both, and I'll show you multiple. There's 3 ways to do pretty much everything in GeoGebra, so that's just one way to select multiple objects. You could also hold Control down on your keyboard and just select the objects out here too. So now that we have those 2 segments selected, I can change both their properties, maybe make these red. Maybe I could change the thickness to whatever I wanted to, but that looks nice. So I'm highlighting those 2 radii. Another nice thing, if you want to get fancy with this, is since we have the 2 segments highlighted, I'm going to right click it and I want to change their properties. So I'm going to go to Object Properties, and there's a Decoration tab. So if you want to get fancy with GeoGebra, you can change the decoration of the segments, and we can put congruent and parallel marks on segments. So let's show that these 2 segments are congruent to each other. So now that we have the marks there, we can see it. Okay, let's go ahead and do the same argument for proving that this segment AP and this segment PB are congruent. I'm going to grab my circle tool again, center at P, and then goes out to one of those points. Okay, so now we can do the same logic here, that this radius right here. Okay, so we got one of our radii of this circle here. Let's get this other radii constructed here, and then again, if you wanted to get fancy, we could leave it maybe black this time, but we could change the decoration again to showing that they're congruent. So there's our kite. So what I like about GeoGebra as well is the capability to just say, okay, here's a picture, here's the geometry on the picture, this is why the construction works. And then when you're done with that, you can actually, if you right click on the picture somewhere, you can see this show object button here. Let's click on that and it'll hide the picture. And so now we just have the geometry here. Okay. This construction should be familiar to students if you've taught how to construct perpendicular lines, because if you had a segment, for example, like let me do this construction over here. If I have a segment here and I want to construct a line that's perpendicular to this segment and goes through, say, this point here, then our construction says make a circle that goes out to I, centered at an endpoint, centered at an endpoint, and then where those two circles intersect at I, I'm just clicking on the intersection and it'll actually put the point there for us. We just constructed the perpendicular line through that point, and that's exactly what we're doing here. So there's a nice connection between two constructions that we can make, and GeoGebra makes it nice and easy, and we can actually change and you know, these points. This is the nice thing about dynamic software. And I can grab my segment tool, and maybe I'll make my segments green and show that we have this kite made in both constructions. So we can make connections using the same construction, just using the properties differently. And that's exactly what we're doing with the angle bisector. Okay, so that is how we could take that angle bisector question, that NAEP item question, use GeoGebra to show some nice concept building ideas that help students remember why they have to do the construction and maybe be able to perform it later if they're ever asked to on a test. So thanks guys, I hope you appreciated that video, and please write me something in the little dialogue. I don't know how that works yet, but write me some if you have questions, or if I screwed something up, please correct me. I'll try to, it's intimidating to talk, you know, knowing that this video is going to go out to the world basically, but I'm willing to put myself out there. And again, if you have any issues with what I say, or if you have any questions about what I say and are curious about things, also, if I went too fast on the GeoGebra and you need some extra help in videos, I could break down things more and put them on this site too. So I'm here to serve you guys, and I hope that I can help you appreciate this GeoGebra program. So thanks guys.